So yes, Vantage6, and a demonstrator specifically about that. So first of all, a very small background of what is Vantage6, and it's basically the personal health train implementation of the infrastructure developed by IKNL, and it has some history coming back to the Pi Task Manager going into PPDLI and then being renamed into Vantage6. So don't see these products as different kinds of products, but see them as previous versions. So Pi Task Manager and PPDLI are previous versions in line of Vantage6. How it works is that you have a central server, which is a kind of message broker. So it handles authentication, who can access the infrastructure, keeps track of the computation requests. So researchers sending computation requests to nodes, for example, hospitals, and stores the results and receives the results back of these hospitals. So that's what the server does, mainly as its main jobs. Then the node are in the hospitals, and the nodes have access to the data. It listens for a request to execute something from the server. It downloads then the analysis, so the Docker image, runs the analysis and sends the result of that analysis back to that central server. The researcher therefore only communicates with the central server and asks, can you run this analysis on these and these and these nodes, for example. So that's a high-level overview of how that works. So basically, as a researcher, you don't interact with the nodes or with the hospitals itself, but you only interact with that central server, which means that there is only an indirect communication between the researcher and the hospital itself. Okay, so how does it work then actually? As mentioned already before, the researcher has no direct access to the nodes, and only the server maintains these connections. So how it works is that as a researcher, you can create your analysis and store it on the central server, so named the Docker registry. And then the user or the researcher will authenticate with that central server as well to log in and say, hey, I'm part of this collaboration, for example, where there are several nodes in there as well. So the nodes over here. So then the researcher says, I want to create a computation task on the server. Okay, creating the computation task here. That can be one or multiple for different nodes. And what the node does is if it's running, it asks every time, are there any available tasks which I need to execute? And it asks that over here. So then the central server, if a researcher pushes a task over here, then the node will pick up the task from that central server. And what it does is say then to the central server, okay, I've received it and now I'm going to process it, so that there's a status update that the researcher can check what's the status. Then the node will pull the actual analysis from the central server. So it will retrieve the analysis, will then execute the analysis, and the result of the analysis, that's over here, will be sent back to that central server. What the researcher can do in between every time is ask, what's the status? And at some point, if it says, okay, the status is completed, then the researcher can pull, so that's happening over here, then the researcher can pull the results actually from that central server and maybe combine the results of different nodes in there to give one combined result. And then he can, of course, make a visualization out of that or whatever he or she wants to do. Mind that this is one of the easy scenarios where, let's say, the pooling of all the results from different nodes, so for example, the mean from master and the mean from another hospital and so on, is happening on the researcher side. There's also an option that you have some kind of master node in your organization where you have then a node for it found everything what it needs. A node for, let's say, a third party which integrates all the results. and then you only retrieve the integrated results from all the data nodes from that integration or that master node. So that's how it in general works, and this overview can be found basically also on that Vantage6.ai website. Okay, so but what's the problem now is that if you look at the manual, which is on docs.vantage6.ai, is that if you need to install it, you need several different computers. You need one server to run this part, basically. You need multiple machines to simulate all these different nodes, and then you need your laptop as a researcher to do all that stuff. So you need to set up multiple different machines and servers to get started, right? Which is not interesting or not handy for a researcher who just wants to check out if this analysis is working, or if he wants to build his own analysis, or these kind of things. You don't want to be involved, bothered with all the infrastructure setup. So this installation manual is more, let's say, if you're in a collaboration, and in that collaboration you want to set up the infrastructure for good. That's what we've done as well, let's say, on the central server, what Ananya is using, for example, for AtomCAD. But it's not something if you want to play around or test analysis or algorithms on your local machine. How, if we want to do local testing? First, what I want to give you is a more short explanation of what we've now built at the moment. So mind, it can go very deep technically, but in the demo later on, it will show that in practice, for the researcher using it, it's not that complex. So how it works is you can do this on different machines, and the machines are here. Your machine is here represented as this gray box. This machine can be a Windows 10 machine, for example, using WSL version 2, Mac OS, or Linux. For the current demonstration, I'm going to use Windows 10 using that WSL 2. And what you have then on that machine is basically two things. You have your environment as a researcher, and you have your whole Docker engine or Docker environment. I've put here, let's say, a Docker socket as well. I'll come back on that later, why you need that. What you have to think about the Docker socket is basically compared to a power outlet at home, where you can plug in your power cord, or maybe an outlet or a socket where you have a network connection. Basically, that's how your computer interacts with Docker. So if you say Docker run hello world, it will ask the Docker socket, can you run that hello world command, and will execute that within your Docker engine environment, basically. So the Docker socket is more of a kind of API to talk to Docker itself, or the system of Docker. So what we've installed in there, or prepared in there, which is being built up automatically, is that you have three different isolated environments. So you have the central server. So the isolated environment is a red box, and then you have a Docker container running, which is called the central server. You have that running in here. And then we have two nodes running, basically. One node is called Vantage6 Maestro user, and one is Vantage6 MEMC user. And both nodes have a CSV file located in there from the Lung1 dataset, both containing 10 patients. So that's the same dataset as what we used in the previous, let's say, hackathon demonstration for making data fair. We have basically this infrastructure. You see the nodes are communicating with the central server, asking every time, do I need to execute a task? And then your researcher code to trigger a task comes from outside on this web page, so localhost port 5000. So this is the basic setup, what the demonstrator repository, which I'm going to talk about later, what it will give to you. Then, as a researcher, you can submit a job. For example, give me the summary statistics of all these different, of all the patients you have in your station. And what it will do is, if you submit the job here, to the central server. Then both nodes will pick it up, saying, do I need to execute a task? If the answer is yes, then it will retrieve that summary statistics Docker container. And basically what then happens is that the nodes, so these two, are going to say to the Docker socket, yes, please run a new container for me or start a new container for that specific execution. And that's this one, let's say, for the master side, and this one for the MEMC side for this node. What that also means is that these execution containers have their own isolated network themselves, so they can't communicate with anything in the current infrastructure or current network. And what you see there is that the CSV file, which is connected to that specific node, to that specific hospital runner, let's say, is now being copied in that container as well. So then it will calculate the summary statistics for that node, basically, and will send the output, or let's say the node will retrieve the output of that container back when the calculation is finished, and then we'll send that result back to the server, so that in the end the researcher can retrieve from the server the results which have been calculated. So basically it's a three-step or multi-step process. So the researcher sends a request to the server. The server, or let's say the nodes, will check, do I need to do a task? Yes. Okay, then create a container to execute the task. Then go back with the result of the task, and the result is then being pushed back here where the researcher can retrieve it. So that's all happening then on your computer. So how does this work in practice? Because this looks very complex, basically. And for that, I've prepared basically a demonstration Git repository, which is publicly available on this link. And we can walk through that now. So if I click on this link, then it will open up that repository. And there is a very short README file how to run all of this as an infrastructure, but we can walk through this. So first of all, what you can do is you can download that repository on your computer. So if I say copy this URL and go to the terminal, go into the WSL terminal, so the Linux environment, I can say git clone. I'm not sure if this is too small. I'll make it a little bit larger. Git clone, and then this repository, which I copy pasted from the link here with clone. So if I do that, it will download that whole repository, and I can go into it. So I can say go into Vantage6 Docker demo. And what we have then downloaded is the following. As you see here, it's the same folders and data as what's in that repository. What you see then in that repository is that we have a folder for the server with all the configuration. We have two different folders for one node called Mastro, one node called MEMC, and we have a folder for the researcher, what he or she is doing. Yes, so, but what we need to do now is we can say run the whole infrastructure, and that's basically by executing the command called start all. So if I say sh start all, what it will do is it will download the whole infrastructure, the software for the infrastructure, everything, which downloads. You can also check that whether it's running. If you go, for example, to your Docker engine on your computer, right-click on that figure and say dashboard, then you'll see the actively running Docker images, for example. And you see here we have a Vantage6 server, we have a Vantage6 Mastro user, and we have a Vantage6 MEMC user up and running. So the whole infrastructure is running. And I think if I click on it, you can also see that it shows the logs of what it's doing, and what it says at the moment is waiting for a new task. So you see it's up and running. It found everything what it needed and is running. What I mentioned before, there are also these CSV files. So for example, from Mastro in a data folder, there is this clinical one data set. And what this clinical one data CSV file holds is basically several parameters from the lung one data set. So it has, let's say, can I quickly change that? Yes, comma. Oh, was I too fast on this? Oh, this one. So it has an identifier for the patient, has the age, the clinical T stage, clinical N stage, clinical M stage, overall stage, histology, gender, and survival time, and outcome, survival, yes, no. Okay, so and for the other station, we have a similar data set from patients 10 to 20, basically. Don't save. So now we have the infrastructure up and running. We can go basically into what the researcher can do to trigger an analysis. And that's what we've prepared in this researcher folder. There are two examples in there, one for R and one for Python. And for this demo, I'm going to use the Python example. And there's three files in here. One is to run everything, which downloads all the requirements and dependencies and everything. And then it triggers this actual Python file to run it. And what if we look at what that Python file does, is it uses a library for Vantage6, a client library, which you can use as a researcher. And with a client library, the first thing what you can do is you can log into the infrastructure, in this case on localhost 5000. So going back to the presentation, where we are now is basically that we are here in this part of the code and therefore connecting to that localhost 5000 to communicate with the central server. So here we first log in with a very good username and password at the moment, but for demo purposes, that's okay. And then afterwards, what we say is we want to run a summary statistics container, and it has some input arguments. For example, what it wants to know is how to treat all these different variables. Is it an integer? Is that a category? Is that yeah, you name it, right? What's the kind of variable in a pandas kind of data structure in this case? So we specify this input definition, and then afterwards we're going to say, okay, post on the central server a request that we want to execute this Docker container, so this analysis image, for this collaboration ID 1, with the input given above, so that's this complete input file, and run that on organization IDs 1 and 2, so Mastro and MUMC in this case, as the simulated stations what we have. And then what it does afterwards is it retrieves the task ID, which was assigned by the central algorithm, and then it goes into a loop to check, are the results there yet? If not, then wait again. Otherwise, retrieve the results. And of course, if it's more than 7 attempts, then stop as well, because then maybe it's going to fail or something like that. Okay, so this is the whole script which is running and which retrieves us the summary statistics of both data sets from these two CSV files in the different stations. So as a researcher, I can execute this code. So I can go into the researcher folder, Python, and then say run. And first it will download all the Python dependencies, what it needs. So this is if you haven't installed all the Python stuff on your computer. That takes some seconds. And afterwards, yes, you see here, these are the printouts coming actually from the code. So attempt to log in to the Vantage6 API, requesting to execute the summary algorithm, wait and fetch for results. And if we would check here into Docker, you see also all the messages popping by that it's trying to do and run the whole infrastructure and the results in there. So this is what it's doing, and then after several waits or several minutes to wait, it will produce results. Now it says none for some reason. Try it again, because I had this issue as well. I need to fix that still. So this is for the MEMC station, for example. You can also check that for, let's say, the central server. And then you see also the messages for the central server passing by or the logging files. And in the end, what it will produce is, in this case, a JSON output where it says, yes, could I find all the correct column names? Yes. The number of rows found is 20. That's correct because every node had 10 records or 10 rows. And then for every column in a data set, this is the column called ID, it will produce the, let's say, summary statistics. So minimum of 1, maximum of 20, none is 10, mean is 10.5, and so on. Medians, then the age, it has a minimum of 56 and a maximum of 84, with a mean of 73 and a standard deviation of 7, for example. Survival days, and so on. What I also already found out is that these are only calculated yet in the default Vantage6 infrastructure for numerical values. They're not calculated yet for categorical ones. So that's something we want to extend ourselves or make our own algorithm for that, or extend it or implement it in the standard summary algorithm what Vantage uses. You see it produces the results, and basically what we have done is we executed 2 commands from this repository. One command was to get the infrastructure up and running, and the second command was to, as a researcher, run this infrastructure. Of course, if you're going to develop algorithms, you want to run different algorithms and these kind of things. So then you're more interested from the researcher perspective that you trigger different Docker containers, and there's a whole manual how to create these containers and these algorithms, so that, for example, you're not running this image, but for example, Jeeves used my test, if I would name my algorithm that way. And also, if you want to use different data sets, you can definitely do that. But at the moment, it's limited to that you need to specify a CSV file in this folder, and then need to include that in the proper configuration file as well for Vantage, that it reads that properly, and so on. So yeah. So this is what it's actually doing and running, but it gives us a basic stepping stone to do more things in there, basically. Let's see, what did I have more? So conclusion, yes, and it works for basic queries at the moment, given the CSV file. And this repository, as mentioned before, can be used as an example. And with a client library, you want to test that locally on your computer. So if you don't have an infrastructure ready to test it on. And I think also the components are reusable for deployment. For example, the central server folder is actually the same as what we've now deployed on our central server running in Azure. Meaning that this script, what you see here, of course, outside of the whole authentication and username passwords, what we needed to define and who has access to things. So here you see this is what we need to load in to create the whole infrastructure in the infrastructure with usernames and passwords and all these kind of things. But let's say you can reuse these components as well to quickly boot up an infrastructure on a central server. Or maybe if you go to Mastro, that you say, I'm using this folder to quickly set up a station on there. So that's there. What does in future work? One of the things what I'm doing in there is integration tests coming from a more software development perspective, because we have multiple things here. We have the infrastructure, and we have the algorithms. And basically both need to work properly before you can spit out a result. And given these static files, what we now have with that clinical 1 and in the other node, that clinical 2 data set, so data here, clinical 2, because we have static data files, we also know what we expect what would come out of the analysis, right? And that's basically this result. So what we can do is build a whole script which runs the infrastructure, triggers the analysis, and gives you back this result. As soon as it's not going to give back this result, then something has been updated in the infrastructure, but now your algorithm is not going to work anymore on the new infrastructure, or your algorithm has changed in such a way that it doesn't produce the same results anymore. But at least that we can test and flag when these things are going on. So that's one thing what I'm doing at the moment. And I think one of the dire needs that for us, what we have at the moment is that we want to get access to Sparkle endpoints instead of loading the CSV files. Because now copying over the CSV files is fine, but what if you have data which doesn't fit in one table? Let's say if you, for example, have a patient and an observation or multiple observations, then it's not going to work anymore in the CSV file, and then you want to connect to a database or a Sparkle endpoint. There are options in there, for example, in Docker, for example, using local overlay networks so that you don't open up this isolated environment to the whole world, but only to that database, for example. But it's something we have to talk to IKNL also with to support it and how we're going to implement that. So yeah, so that's basically it. And if people want to try it out, definitely you can go to this repository, download the code there, and then try to run it on your machine. So with that, I'm at the end, and maybe there are some questions or remarks or things how we can improve this demonstration. That's yeah, definitely helpful.